Today, 2.6 is families of functions. All families start with a parent function. The parent function is the most basic form of the function. Now we're going to take the most basic form and we're going to do things to it. We're either going to move the basic form up, we might move it down, we might move it to the right, we might move it to the left, we could stretch it, we could compress it, could flip it around, do lots of different things with it. Okay, so that's the idea. All those other options work off of the parent function. So here's where we're going to start today. We're going to start with, if I have a function, so I'm going to call my function f of x, and I add something to the end of it. We're going to call that k. K represents whether the function moves up or down. So if you have a function and then you have something added to it, you're going to move up that. If it's subtracting it, you move down that. So here we go with example number 1. All right. Describe the translation of the parent function y equals x. All right. So let's say I have y equals x plus 7. Because I have taken my parent function and added 7 to the end of it, it goes up 7. Let's say I have y equals x minus 4. Again, I have my parent function, and this is going to go down 4. So let's kind of imagine what's going on here. My parent function is the y equals x line that goes right through the origin. My up 7 would move up to where my y-intercept is at 7, and of course my slope is the same. And if I have x minus 4, I've taken that same parent function and moved down 4, and again my slope is, oh, that's not very straight. My slope is the same. Okay, so we've just shifted it up and down because we've added a number to the end. Not so bad so far, right? Okay, example number 2. Make a table of values after the translation. So let's say I give you a table of values. Here's my x and my y. That's really not very straight. Sorry, guys. Let's say my table of values is negative 2, 4, 0, 7, 2, 9, and 3, 12. Okay, and I say I want to go up 3. So I'm going to make a new table of values over here. When I am going up 3, does it affect my x or does it affect my y? What? Because it's on the y-axis, it's moving up. So all of my x values are going to stay the same. all of my y values, I'm going to add 3. So this one becomes 7. 7 plus 3 becomes 10. 9 plus 3 becomes 12. And 12 plus 3 becomes 15. It affected our y-axis. All right, let's also try this the other direction. Here's example number 3. Yep, sure can. Is that good? Okay. Okay. All right, write an equation for the translation of y equals f of x. So it's going to give you that in the directions, and then it's simply going to say 2/5 units down. So we are going to write an equation. Now, that means we are simply starting with what we have, which is y equals f of x. And if we're going 2/5 units down, what are we going to put at the end? Minus 2/5. That's exactly right. Minus 2/5. If we are going 7 units up, we're going to say y equals f of x. And then if we're going 7 up, I'm going to put plus 7. Exactly. Any questions so far? No questions at all? Yes.
So, like, when f of x just means, like, y, right? Like,
F of x is just your function, yeah. It means y, it means whatever function you have going on.
so, like, why do you have y there?
It's just saying it's the same thing, but now I've added 7 to move that function up. It's just notation. Okay? All right. So we moved up and down, and we totally get that. That's the easy part of it, is moving up and down. Now we're going to move right and left. Okay? Now, the tricky part of moving right and left is it's always inside with the x. So what I mean by that is I have y equals f of x minus h, where h represents right or left. Now, the easiest way to do this is to take whatever inside with x, whether it's in a parenthesis, in an absolute value, inside a square root, and you set inside equal to 0, and solve. So even here, if I set this equal to 0 and I add h over, I would go to the right h. If I happen to have x plus h and I set it equal to 0, I go to the left h, because it would be a negative. Okay? We're doing all right? Okay. So I'm on to example 4, correct? All right. So this time, let's use the parent function. Describe the translation of the parent function right now. Probably a good call. And this time our parent function is going to be y equals x squared. So the first one I have is y equals x minus 5 squared. So technically I take what's inside where x is, this x minus 5. I set it equal to 0 and I solve it. I get x equals 5. This means that I go to the right 5. Okay? Let's say I have y equals x plus 3 squared. I would have x plus 3 equals 0. If I subtract 3 to the other side, I get x equals negative 3. This would mean that I go to the left 3. All right, what if I had y equals x minus 12 squared? What am I doing here? Set it equal to 0, so x minus 12 equals 0. So I add 12 over, I get x equals 12. So where am I going? To the right 12. All right, any questions so far? We are all the way through question number 18. We're doing fabulous. Yep, I know. All right, next. Example number 5. For example number 5, make a table of values. For f of x and f of x plus 2. So, I'm going to actually put it both in the same one, for example. Let's say for my f of x, here's my x and here's my f of x. And they give us 1, 3, 2, 5, 3, 1, and 4, 0. This says that I am moving which direction? We are going left 2. What one is that going to impact? The x or the y? The x value. So in our new table, we have x and we have f of x plus 2. We are moving our x value left 2. So I'm going to move 1 left 2 to negative 1. The 3 stays the same. If I have 2 and I move that left 2, where is that one going? 0. And the right one stays the same. 3, if I move that one left 2, I get 1. The y stays the same. And 4, if I move that left 2, and 0 stays the same. Now this question in your homework actually now asks you to graph both tables. So we're going to start by graphing the first one. 1, 3. 1, 1, 2, 3. I'm going to put a dot right there. 2, 5. 3, 1. And 4, 0. All right, so this is kind of what we have going on. Everybody agree? All I did was connect my dots from the first one. So now, let's see when I do my second one if it has moved it over 2. All right, so negative 1, 3. 0, 5. 1, 1. And 2, 0. Does it look like the same thing moved over 2 units? Hopefully. That's the idea. So you have to do one of those in your homework today. Okay. We're doing great. So, next thing. So we've talked about moving it right and left. We're going to get there. And we talked about moving it up and down, and we talked about moving it right and left. So now I want to talk about how it reflects. All right, reflection. if I have y equals negative f of x, so there's a negative in front of my whole function, this flips over x. If I have y equals f of negative x, this flips over y. All right, so here is example number 6. Write a function rule. To represent the reflection. So on these problems, and this is your 23 through 25, if let's say I have f of x equals 7x, and then it says they want you to reflect it over the x-axis. In order to reflect it over the x-axis, the whole function has to turn negative. So we would rewrite this as f of x equals 7, or negative 7x. That's it. Okay? All right. What do you need? Yeah, go ahead. You're welcome. All right. So now we have one last thing to talk about. Yeah, no problem. We're going to talk about stretching and compressing it. Okay? When we stretch it, the bigger the number inside or in front, the bigger the number in front, the more it stretches. So I like to think of it as if I had a u and I put a number in front of my equation for that u or that parabola. It's like taking those two ends and pulling them up closer. So it gets skinnier and skinnier and skinnier. The bigger the number is, it gets skinnier. If I had a fraction in front of my equation, what it actually does is it pushes it down and it gets flatter. Okay? So you got to kind of think of it almost like it's a rubber band. The more I stretch it, the skinnier it gets. Right? The more I push down on it, the fatter it falls apart. Okay? So that's what we're doing next. So we're going to talk about stretch and compress. So if I have y equals a times f of x, whatever that function is, if a is greater than 1, it's a stretch. If a is between 0 and 1, it's compressed. So here's example number 7. Write an equation for the translation of y equals x. So let's say I want to compress 2/3. My function now becomes y equals 2/3 x. So think about what that means. My parent function was that perfect diagonal through the origin, which I missed again, right? This one is now up to and over 3. See how I've pushed it down and made it flatter, closer to what the x is? Okay? You're pushing on it and making it flatter. All right, what if I were to say stretch 9. How do you think that would change my equation? Whoops, sorry. It would change it to y equals 9x. And if I were to draw that, it would be a steep slope way up here, and it would go in this direction. I'd be stretching it up so it's steeper. Okay. Example number 8. I promise I'm almost done. Example 8. Now I want you to put it all together. Describe the translation of y equals x squared. All right, you ready? We have y equals 3 x minus 2 squared plus 6. So we're going to start at the beginning right here. That a value in front is bigger than 1, so this is a stretch. So we're going to say stretch 3. Moving to the parentheses, we set that equal to 0. Which way are we moving for the parentheses part? Right 2. Very good. Right 2. And at the end I have plus 6. What does that mean? Up 6. Let's do one more. Say I have y equals negative 1/2 x plus 5 squared plus 1. So a negative in the front flips it. I'm just going to say flips because it's flipping it upside down. So we'll say flips. This is less than 1, so this is a compress 1/2. Then what does the parenthesis tell us? Left 5. Remember, you want to set that equal to 0 and solve it. So this goes left 5. And how about the end? Up 1. Questions? Okay. Then my last example. Last one, I promise. This is it. I'm on what, 8? 9, really? Example 9. Yes, it is. Describe the translation, I didn't fit in, from f of x to g of x. So let's say I have f of x equals 1/3 x plus 3, and g of x equals x minus 2. All right, so this is where we're starting at. And I did a harder one to start with here. This is where we're starting at. So it's already compressed 1/3. So in order to get it where it's a 1 here, what are we actually going to do to it? We've got to stretch it 3, exactly. So we're going to say stretch 3. Everybody's cool with that? All right, now that one says that we've moved up 3. I need to get where we've moved down 2. So how many do I have to move? Down 5. Perfect. Question. The what? Well, this one has moved up 3, so you're up here. This one is down 2. I need to know, how do I move from 3 down to 2? Is it? That's it. Correct. Very good. Very good, Ethan. All right. Any questions? Let's get started. You guys have about 15 minutes. Okay? So that way, when we have questions, I'm here. All right?